Chapter 11, continuing on with constructor chaining, and then just a short example. So hopefully a relatively painless video. Constructor chaining, what is this? Constructing an instance of a class, constructing an object, it really amounts to invoking the constructors of all of the superclasses along that inheritance chain, going all the way up to the object class. How does this actually work? When you construct an object of a subclass, and of course, everything is a subclass of at least object, right? So even if you have a class that does not explicitly extend some other class, it still implicitly extends the object class, right? So when constructing an object of a subclass, that subclass constructor, it first invokes the superclass constructor before performing its own tasks. That happens if you don't do it explicitly, it happens implicitly. The very first thing that occurs is the constructor of a subclass. The very first line of code that happens is it will invoke the constructor of its superclass. Now, if the superclass is in turn derived from another class, the superclass constructor of it will then invoke its parent. And this will continue on and on and on, all the way through that entire inheritance chain, throughout that entire hierarchy of classes. And this is called constructor chaining. Now that's a lot of words. Most important is, let's see an example. So here's a lot of code on the screen. That code consists of three classes. Imagine they were all together, maybe in a single file or three separate files. We have the class faculty right here. We have the class employee and the class person. And in fact, the next slide maybe helps to partition this for you. So we see here we have the class faculty and all of its code. We have the class employee and all of its code, and the class person. Now do notice, now each of these are classes, are blueprints. Each of these has a constructor. The class person has the person constructor. The class employee has two constructors. And remember, a constructor is identified because it has the same name as the class itself. So each of these classes has a constructor. Employee has two constructors. The class faculty has a faculty constructor. But what is unique here is that inside the blueprint, what do we find inside the blueprint for faculty? We find the actual method main, which is kind of funky at first. Like, why are we putting main inside a class that we plan on creating objects from? Why? Why not? Just to show you another way of coding this up. So now that we understand at least what we're looking at, the three classes, let's really pay attention to the finer detail of what happens when we create a new faculty object. So we can see that faculty extends employee. So when we make a new faculty object, well, faculty is extending employee. So ultimately, we're going to be calling the employee constructor. Well, employee extends person. So when we call that employee constructor, well, it in turn will call the person and constructor. And there's no explicit extending here. But of course, we know that therefore person implicitly, in fact, extends object, and we call that object constructor. This is what's going on. Let's now break it down. Step by step, here's our main, our starting point. We make a new faculty object. We're not even worried about saving the result of that object into some other reference variable. That's not the purpose of this example. We're just going to make a new faculty object, which means we're going to come to the faculty constructor, because again, we're inside the faculty blueprint. Well, here's the faculty constructor. Well, inside this faculty constructor, we have a print statement. We have a print line where we want to print something, but we're not going to execute that yet. You might say, well, it's the only line of code there. It is the only line of code, but what did that last instruction say? If I come back, no problem in doing so. It says when constructing an object of a subclass, the subclass constructor, it first, before anything else, it invokes the superclass constructor before it performs its own task. Now, in this case, what is its own task of this faculty constructor? It would be to do this print statement. But before doing that print statement, what happens? Look here and see, do you see an explicit call to the superclass constructor? The superclass would be what faculty is extending. Do you see an explicit call to the employee constructor? You do not, which means therefore Java will include an implicit call to the no argument constructor of faculty's parent, whoever faculty is extending, which is employee. So right here, you don't see it, but right here is the word super followed by a pair of parentheses with nothing inside them right here. And we're therefore going to call the employee no parameter constructor, the no argument constructor, because there's two constructors employees, right? There's this constructor and there's this second constructor. Well, since nothing was explicitly invoked, we will implicitly call the default no arg constructor of employee, and that brings us right here. So we invoke this no argument constructor. Now what do we see here? You see, well, we have a print statement, and above that we have a this. Now what does this do in general, just as a reminder? If inside a constructor you see the keyword this followed by parentheses, that means we're calling an overloaded constructor of that same class. So right here, this keyword this, what's happening, notice what's inside here in the parentheses, we have a parameter which is a single string, this entire string. And what we're really doing here on this line is we're saying, hey, I know you called this particular employee constructor, but this line then says, yeah, but really, I want you to go call this other employee constructor, and I want you to send over this string parameter and save it right here inside this formal parameter s. So what did we say? We said the first thing that happens is we will call the superclass constructor before performing your own tasks, which is right here. Because there's nothing explicitly written, we call the superclass constructor of employee, the class that faculty is extending, and we arrived right here. So now the question is, are we going to do that again? We don't see an explicit call to super right here. So therefore, can we say that super is really right here? And the answer is no. This is the one exception. So hear me carefully. There's one exception to this rule. And that exception is if a given class is calling an overloaded constructor, you actually do that call to the overloaded constructor. So here, when I come, even though I don't see the word super here, I see that what's really going on is we're calling an overloaded constructor of employee, which brings us right here. So it says invoke employee, the overloaded constructor with this string parameter. Now, we've arrived right here to this overloaded constructor. And here we have a singular task, a print statement. But what happens? Before performing that task belonging to this employee constructor, we need to do what? We need to invoke the constructor of the superclass of employee. If we don't have an explicit invocation. Do we have an explicit invocation? Do you see the word super right here? The answer is no. Therefore, Java will include an implicit invocation right here. Java will include the word super followed by a pair of parentheses, which is going to have us call who? Well, employee extends person. So right here, when Java includes super with that pair of parentheses, we're going to be calling the no argument constructor of the superclass of employee, which is person. So that's going to bring us right here. So now we're at this person class, and this person class has a singular print statement. By the way, nothing's been printed yet. We're doing that constructor chaining. So now we're inside this person constructor, and we would like to print. But before we can print, we need to see, is there an explicit call to the super of person? Well, who's the superclass of person? Person's not explicitly extending any other class, which means person implicitly extends object. We have reached the end of that inheritance chain. Person will therefore implicitly extend object, and there is no explicit invocation to object here. There could have been. We could have typed super with parentheses. We could have done that, but that's overkill. It's unnecessary. So we didn't type the word super here, which means that Java will implicitly include that. So right here, even before printing, we're actually going to invoke implicitly the constructor of object. Once that's done, it will return to right here, and finally, we have our first print statement. We will print this line of code. We will print this string, which is why there's a number 1 there, to indicate that's the first thing that gets printed. What's the next thing that gets printed? Well, after printing, remember, let's back up. How do we arrive right here? Let me back all the way up. How do we arrive to right here to print? Is we did this constructor right here. I'm pointing at the screen. Oh, that's such a big brain moment. I'm literally pointing as if you can see me point. It's so fantastic. Okay, let's do that again. Point with the actual red laser here. So we were right here. We got the overloaded constructor this, which brought us to here. And then here we have a super, which brought us to here. And then here we also had a super, which brought us to object. And now we're printing. And after printing, where are we going to go back to? We're going to go back to what brought us to right here, which was this public employee string. This is what brought us. Remember, we were right here. And from here, we came to person. Well, therefore, after finishing this print statement, we're really going to come back to right here. Okay? So we print, and now we come back to right here. And we just finished executing this super where I'm moving this laser pointer. We just finished that call to the overloaded constructor to super, and now we're printing S. Well, what is S? S is this string that we sent over to the overloaded constructor. So we're now going to print that line of code, this second print statement. After invoking the this, which brought us to here, which brought us to here, which brought us to object, after doing that, we're now going to execute the second line of code inside this employee no argument constructor, and we print this line of code right here with this number 3, employees no arg constructor is now being printed. And then finally, we're back up here to faculty, and we print faculty's no arg constructor is going to be invoked. That's a lot. I'm going to back up one more time. So here, without even clicking the keyboard to move along, we're calling a new faculty. That brings us to here. This new faculty, before I can print, I have a super right here, which calls employees no arg constructor. And here, I don't have a super because I have a this. So here, this is calling the overloaded constructor of employee. And we sent over that string, bringing us to here. And we really have a super right here, which is calling employees superclass constructor, which is going to bring us to person, the default constructor of person. Really, there's a super here, which brings us over to objects constructor. When that's all done, I print this one. Then I come back to here. I print this string, which was really this string right here with the 2. When that's done, I print this string with the 3. And when that's done, I finally then print the faculty. This is constructor chaining. We've spent now, almost 14 minutes, so at least 13 of those minutes, probably about a third of this video on constructor chaining. It is super important to understand the nuances of that detail. How really what gets performed first at the end is once we go all the way up that chain, we perform person's tasks, right? So we ultimately performed person's tasks first. Then we performed this task right here of printing S. Then we performed the employee task, and then we performed the faculty task. That's the order of what really happened. So here's a question for you. It says here at the top of the slide, an example of the impact of a superclass that does not have a no argument constructor. So here, let's look at the code to examine it. We have 2 classes. We have class fruit and we have class apple. Let's pretend there was a main that was calling this. Just assume that happened. We have a class apple which extends fruit, because apple is more specific, fruit is more, of course, generic. So we have class fruit, we have class apple extending fruit. Look at what happens inside class apple. If our main program, for example, had said, make me a new apple. Well, what happens inside apple? We're calling this constructor, this no-R constructor of apple. Well, what's going to happen when you run that code? If you try to make a new apple object with no parameters, and you call with no parameters, and you're going to call this no argument default constructor of apple, what happens? Of course, you can see down here we have a constructor for fruit. It prints something. Think about what happens. Pause the video, look at this code, and ask yourself, well, what do I think happens? And then come back. And I'll give you a hint if you've come back and you were confused. Remember what is implicitly included inside your constructor. So remember, here, we're trying to make a new apple, I said. That was the example. I said we have a main. The main says make a new apple and call the no argument constructor of apple. Well, here we're inside this no argument constructor. Well, what in fact is included implicitly right here, even though you don't see it? What's included? A call to super with no parameters. So we're going to implicitly invoke the no parameter, the no argument constructor of the superclass of apple, which is fruit. So we come to fruit and we look for a no argument constructor of fruit, and we don't find one, which means what? We're going to have an error. There is no argument constructor of fruit, which is what's being called right here with that keyword super. It's implicitly given. And therefore, we would have an error. Now, how could we have avoided this error? One of two ways. We could have included a no argument constructor of fruit, in which case, when we call it implicitly, nothing happens, no error, because that constructor exists. Or here inside apple, we could have explicitly made a call to super, and we could have explicitly, with that call, included a string parameter, which would bring us to this specific constructor of fruit. Either one of those would work. 17 minutes, time for code. This is going to be a short example, I hope. We want to code up a new example with 3 classes. One class will be geometric object. That will be the superclass. And we will have 2 other classes, circle.java as well as rectangle.java. And here is the UML for each of these classes. We're going to be going back and forth with this. Make sure you pause the video and you do all of this code. What I've done here in NetBeans, I've made a new project called Inheritance Practice. Go ahead and do that. I'm going to zoom way in. Inheritance Practice is the name of this new project. Pause the video if you need to. Make your new project with that name. Do not use packages, so delete everything else. And don't call it main. I would call it Inheritance Practice. So now I'm going to right-click on my default package, and let's make these 3 classes. What are they? One is called Geometric Object. So Geometric Object, the G and the O are capitalized. Hit Finish. Let me delete all of this stuff inside. Zoom way in. Right-click, New Package, New Class, and we have Circle and Rectangle. So this will be Circle. Let me zoom way in, delete all this stuff, and then right-click on Package, New Class, Rectangle. And let's zoom again way in and delete all of this stuff. All right, so I got my circle class, the rectangle class, the geometric object class, and here's my inheritance practice class where I'm going to have a main. I'm going to make some of those objects of geometric object, which is just vanilla, of circle, and of rectangle. So geometric object, and this is just an example from a textbook. Frankly, I'm not a fan of the example as compared to the student example with person, with employee, because that makes a lot more sense. It's something more relatable to person objects. We are people, in fact. So geometric object, maybe not as relatable, but it's a good example in a textbook, so we'll use it. So the 2 data members of geometric object are these 2. They're private data members. One is called string, and one is called color, and the other one is called filled. So we have here string color and Boolean filled. kind of like in a photo program where you could make a shape, and like you could make a square or a circle or a triangle, and you could choose the color of that shape, and you could choose whether or not that shape has been filled with that color. Or you could have a border. I could have maybe said Boolean has border, true or false, and maybe border color. I could have done other things. All we're going to do is have a simple color of the shape and whether or not it has been filled. So let's now make the constructors. Notice it requests two constructors. So one of them, right-click, insert code, constructor, generate the default no-arg constructor. Right-click, insert code, constructor. I'm going to select all and then generate. That's the other constructor that was requested. We need to have a get color, a set color, and an is filled and a set filled. Notice it says is filled. I'm not sure if I've mentioned this. I could call it get filled, which returns a true or a false. But normally, when you have a Boolean variable, that is the variable of the data member, it's a Boolean data type, usually the getter is renamed to, instead of get filled, it's renamed to is filled, and it returns a true or a false. That's just a programming, wow, what is the word I'm looking for? More of a programming style. So it's not necessary, but it's more of a programming style. So right-click, insert code, and you'll see that NetBeans, in fact, does that style for you. I'm going to encapsulate fields. I select all of the getters and setters, and you see here, is filled, set filled, get color, set color. So instead of get filled, it was called is filled. And we need to have a toString method. So this will be right-click. Is there a toString option? Insert code. I have not noticed. Yes, in fact, there is. Check it out. So generate, let's see what we have here. This is not what I want to return, but it's good that it saved me some time. So string s equals empty string, return s, and we'll worry about what to include in that string in just a few minutes. So this particular class is done. What does the circle class have? Well, it has, the circle class extends geometric object, as does the rectangle class. So I'm going to copy that and paste it right here. Both of them extend geometric object. Now the circle class, along with extending geometric object, it has its own variable, which is a double radius. And so now we want to make three constructors: the default no parameter constructor, a constructor with just the radius, and then a constructor with all three of those parameters. Right-click, insert code, constructor, generate the default no argument constructor, insert code, constructor, generate the constructor with just the radius, generate, and then finally right-click, insert code, and generate the constructor with the radius as well as with, let's see, as well as with the color and the filled. We want to do this. Let me see. Perfect, and it did it all for us. We sent over those three values. We assigned radius into the radius of this, the radius data member of this class, and then we're calling the superclass constructor, which is geometric object, and we're going to forward over radius, so we're going to forward over color and filled to that superclass constructor. Perfect. Life is so easy with these amazing IDEs. So we need to have a getter and a setter for radius. That's easy. Right-click, insert code, getter and setter, just for radius. Done. And let's encapsulate fields. Done. And now we want to have, right-click, insert code. We want to have a toString, generate. I'm just going to delete this again. And I'm going to type string s equals new string, return s, and we'll deal with what goes inside that in a minute. And now we have other methods as well. We have a get area, get perimeter, get diameter, and all of those are public methods that return doubles. So let's type those. Public, double, get, so we have area, perimeter, diameter. Get area. I'm going to put just return 1.0 for now, so NetBeans will stop shouting at me. Public, double, get diameter. That should be easy, right? We have get area, get perimeter first, and then get diameter. So here I'll put public double get perimeter return 1.0. Cool. So now we have really coded all of this up, and we can come put some comments in here. This is data members. Here we have constructors. Here we have getters and setters. And then we have other methods. This is my style. You can make your own style. I just like to be able to distinguish data members, constructors, getters and setters, and then any other methods we need. We can actually knock out these other methods pretty quickly. Given a radius, right? We have a radius. What is the diameter? The diameter is just 2 times radius. So that's easy. And recall that I don't need to put this dot radius here because there's no ambiguity, right? There's not like some radius as a parameter. So there's no ambiguity. When I just type the word radius, Java knows we're talking about the radius that belongs to this class, the data member radius. So I can just type 2 times radius. If you want to put 2 times this dot radius, you can. And what does it say? Yeah, it's not even calling it out because it's not a problem, but it's unnecessary. Okay, what is the equation for area of a circle? Pi r squared. So math dot pi. Check it out. We can use the library directly. Math dot pi times radius. Done. What about get perimeter? What is the perimeter of a circle? Does anyone remember? 2 pi r. So 2 times math dot pi times radius. There are those 3 methods. We'll worry about what goes in the overridden string method in a few minutes. Let's come over to rectangle. Rectangle, we have a width and a height. So, and they're both doubles. So double width, double height. Let's insert how many constructors? 3 of them. The default no argument constructor, a constructor with width and height, and then a constructor with width, height, and the other 2 data members, color and filled, which really come from the parent class geometric object. Insert code, constructor, here's the default, no argument constructor, insert code, constructor with just width and height, done, right click, insert code, constructor, nope, wrong button, come on, right here, right click, insert code, constructor, select all of these, and I'm going to select this one specifically, which has color and filled. Done! Makes it so easy calling the superclass constructor automatically for you. We need to have a get and a set width, a get and a set height. Let's knock that out. Right click, insert code, getters and setters, select all of them, encapsulate fields, done, and it made it private for you. How beautiful. Let's make some comments here. Data members. Another comment here, constructors, and then finally a comment here, getters and setters. Done. And now we have other methods. What are the other methods? We have a get area and a get perimeter. So public static, not a public static, public. It is going to return a double for the area. Public double get area of a rectangle. I would hope we know how to do that. What is the area of a rectangle? It's just going to be width times the height. And public, let me come down some, public double get perimeter, perimeter. And what is the perimeter of a rectangle? It's 2 times the width. You have 2 of the widths and two of, wow, I did like this. Then I said 2 of the widths when I did that. I should just cry. I said, it's been a long week. I said 2 of the widths, measuring the height. That is fantastic. So 2 of the heights plus 2 of the widths. So return 2 times width plus 2 times the height. And if you feel better about it mathematically and you want to come put in some parentheses, you can, or if you just remember your PEMDAS, you know that multiplication happens first. But if you want to feel better about it visually and put those in parentheses, no harm, no foul. We're good there. What is the final thing? We need a toString. right click, insert code, toString, and we hit generate, and I'm going to delete this, and I'm just going to do the normal string s equals empty string, and then return s. So I think we're ready to go make some objects, and we'll worry about the toString in a few minutes. Let's come over here to the inheritance practice. Let's make a geometric object. Let's call it Geo, because I'm very creative. Equals new geometric object. And which constructor do we want to call? We want to call the one that receives the information. So color and filled. So let's say the color of this one is red. And let's just say true, that it is filled. Cool. Let's make now a circle object. So circle C equals new circle. And what does the circle object constructor look like? The main one that receives everything. It has a radius, a color, and filled. And so I'm going to come here and let's make the radius of this circle 5. And let's give it let's make it 10. And let's give it a color of blue. And yes, it is filled as well. Finally, rectangle R equals new rectangle. And what comes inside here, if you come back to the constructor of rectangle, let's send over all 4 things: a width, a height, a color, and a filled. So let's give this width of the rectangle 6, the height will be 8, the color will be pink, and is it filled? Let's say false. Let's say it was not filled. So we've now made those 3 objects. Can we print them now? Why not? Let's come right here and let's print the the geometric object. Let's print the circle, and let's print the rectangle. And I run this code, and what do we expect? We're going to get that nasty, that trash toString method of the object class. And well, we got, oh, wait, no. We got nothing. Is there an explanation for why we got nothing? Of course there is, because we in fact already overrode the toString methods in each of those, but we didn't actually put anything in it. So it's really just returning an empty string. So let me comment out each of these. So let me comment out each just so you can see what it would have looked like. I forgot we had put the empty string in there. So if I got rid of this and I come back to here and I run this code, we get those nasty, useless, we're calling the toString of geometric object, which is borderline useless, right? So instead of doing that, what do we want to do? We want to actually use those 2 strings that we made. So let me uncomment this. And so now let's make, when I run this code now, of course, it prints out 3 empty strings because that's what each of these are. Remember, this is really calling the toString, and it's not calling the toString from object, it's calling this overridden toString, which really has nothing. So what do we want to do here? We want to say s plus equals, and we want to be able to print out the various components of this object, which will be what? The color. Let's do string.format, color, colon, put a lot of spaces because we're going to have the word diameter. I'm thinking about the other things. I'll put that many spaces. The color, %s, new line, and here we're just going to print color. And s plus equals, and we want to print out filled, yes or no. Is it filled? We want to print yes or no right here. So I could have done this in an if else, but what a great chance to just use a ternary. So I really want to be able to print a yes, or I want to be able to print a no, right? So, and how can I choose whether or not to print a yes or a no? Based off of whether or not, I'm working backwards here, based off of whether or not the variable filled is true. So check that out. If filled is true, it'll print a yes, otherwise it'll print a no. Done. So now, if I run this code, and let's just say that I had actually not included this overridden method here for circle, And also if I had not included the overridden method there for rectangle. And I run the code, now what am I going to get? I'm going to get that the color is red for this geometric object, and it's filled is yes. For the circle, the color is blue and it's filled, and here for the rectangle, the color is pink and it is filled. That's great. So what we want to do now is we want to be able to come and in fact override each of the two strings in circle and in rectangle as well. So we're going to say here, by virtue of extending geometric object, this circle class has inherited this much better two-string method. It's much better than the trash one from object. So it inherited this, and so we have a much better two-string method. But after inheriting, we say, you know what, that's a good method. I mean, it does in fact print out blue and yes, but it's not printing the radius or the area or the perimeter or the diameter. So we can improve. So how about we say, well, let's concatenate 2s. First, let's concatenate the actual information from the superclass. So let's say super dot toString. So now we're going to call the toString of the superclass, this right here. It's going to return this entire string, and it's going to get concatenated into s. Now, after doing so is where we want to go ahead and print the actual components that belong strictly to the circle. So I go ahead and I copy this line of code just so I can make my alignment nice. So this is going to be radius, it needs to be that long, and radius. And radius, of course, is a double. Let's make it 0.2f. Here we're going to have, after radius, diameter. What is diameter? Also a double. And this is going to be 0.2f. And how do we call diameter? It's not a data member. I can't say diameter. It's a method. So I can say get diameter. Done. What about area and rectangle? Same exact thing. Paste, paste. I said rectangle. Area and perimeter. Area is going to be this. Get area. And then the perimeter. Fix the alignment. And this is going to be get perimeter. Done. Let's now run this. What does it not like here? Oh, yep, it's missing an extra. There we go. Let's now check out that result. When I run it, wow, look at this. Colors blue, filled, yes, radius 10, diameter 20, areas 314, which makes sense, right? Pi r squared, 10 times 10 is 100 times pi, perfect. And the perimeter, 2 times pi times r, that's exactly what we would expect. Nice. What can we do now? The same thing over here for rectangle. So this is not really practicing anything new. It's just practicing a second example of what we've already done now with student and with employee. So rectangle is going to look pretty much the same. So I'm going to copy all of this to save some time. I come over here to rectangle. I paste. And so, of course, now instead of radius, what am I going to have? I have width. Let's fix the spacing. And this is going to be width. And I have height. Fix the space. And this is going to be height. And then what are the other components here? And width and height, by the way, they are both doubles. And so I'm thinking this is, of course, missing a right parenthesis. And now I need to print the area and the perimeter. And guess what? It's already done because they were the exact same method name. Check it out. Let's come back, run our code, and this is what we get. Here's just the geometric object. This is the actual circle. And here we have a geometric object of type rectangle. And of course, I could have included the type if I wanted to. I could have come up here and said, you know what, before I do anything else, let me concatenate s plus equals the type. Maybe I want to concatenate circle with a new line. So now when I run this line of code, or when I run this program, let me concatenate circle. Here I'll come concatenate the same thing, rectangle. And so therefore, after I type this up, rectangle, and I come run this program, now it's actually named. We have a circle, and here we have a rectangle. So this was just to run through another example of practicing making some classes, making a superclass, making these subclasses, making the various constructors, have those constructors call one another, right? We had this superclass of geometric object, and here's the subclasses. Well, in the constructors, have them call the superclass, explicitly call them of the superclass geometric object, have that done, have the same thing done with rectangle. Another good example, and guess what? We are in fact done. Let's go. It's as always been a blast. Reach out if you have any questions, leave a comment. Until next time, take care everyone.